At the center of our solar system is the Sun, a giant ball of burning gas. It provides us with light and warmth, making life on Earth possible. But like all stars, the Sun has a life cycle. It will not shine forever. Currently, the Sun is in its main sequence, where it has been for billions of years. During this phase, the Sun fuses hydrogen into helium in its core, releasing tremendous energy. This process is what fuels our star and allows it to shine. The Sun is about halfway through its main sequence lifespan. It has enough hydrogen fuel to continue burning for another 5 billion years or so. This may seem like an eternity, but it is a blink of an eye in cosmic terms. Once the Sun exhausts its hydrogen supply, it will enter the next stage of its evolution. This future stage is a dramatic one, with significant consequences for the inner planets of our solar system, including Earth. Understanding the Sun's life cycle gives us a glimpse into the future of our own planet and the destiny of other star systems throughout the galaxy. As the Sun's core runs low on hydrogen, it will begin to contract under its own gravity. This contraction will cause the core to heat up even further. The increased heat will cause the outer layers of the Sun to expand outwards, engulfing Mercury and Venus. The Sun will then transform into a red giant, a star that is much larger and cooler than our Sun is now. When the Sun becomes a red giant, it will be a truly awe-inspiring sight. It will appear much larger in the sky than it does now, and its color will shift to a deep red. However, this beauty will come at a cost. The intense heat from the red giant Sun will boil away Earth's oceans and scorch its surface. Our planet will become uninhabitable. The red giant phase will last for a few billion years. During this time, the Sun will fuse helium into heavier elements in its core. This process will release even more energy, causing the Sun to expand further and shed its outer layers into space. The red giant phase marks the beginning of the end for our Sun. It is a slow, drawn-out process, but it is an inevitable one. The once life-giving star will become a harbinger of destruction for the inner planets. As the red giant Sun sheds its outer layers, it will create a spectacular cosmic display, a planetary nebula. This expanding shell of gas and dust will glow brightly, illuminated by the dying embers of the Sun's core. Planetary nebulae are some of the most beautiful objects in the universe, their intricate patterns and vibrant colors captivating astronomers for centuries. The planetary nebula phase is relatively short-lived, lasting only a few tens of thousands of years. During this time, the Sun will continue to lose mass, its outer layers drifting off into space. The nebula will gradually disperse, eventually fading from view. What will remain of our Sun is far less impressive than the red giant or the planetary nebula. The Sun's core, now depleted of its nuclear fuel, will shrink and cool, transforming into a white dwarf. While the inner planets face a fiery demise, the fate of the outer planets is less certain. As the Sun expands into a red giant, its gravitational pull on the outer planets will weaken. This could cause their orbits to shift outwards, potentially saving them from being engulfed. However, even if the outer planets survive the Sun's expansion, they will not be unaffected. The intense radiation from the red giant Sun could strip away their atmospheres and boil away any liquid water on their moons. Despite these challenges, there is hope for the outer solar system. As our Sun evolves, it will have a profound impact on the icy moons of the outer solar system. Two of these moons, Europa and Enceladus, are particularly intriguing. These moons are thought to harbor vast oceans of liquid water beneath their icy surfaces, potentially offering suitable environments for life. As the Sun expands into a red giant, its heat could melt some of the ice on Europa and Enceladus, potentially creating conditions that are even more hospitable to life. These moons could become temporary havens for life in our solar system, albeit for a limited time. However, this period of potential habitability would be short-lived. As the Sun continues to evolve, it will eventually become a white dwarf, a faint, cooling ember of its former self. The white dwarf Sun will not emit enough heat to sustain liquid water on the surfaces of Europa and Enceladus, and these moons will eventually freeze solid once more. The future of our solar system is a tale of both destruction and renewal. As our Sun transitions into a white dwarf, it will gradually cool and fade, its faint light casting long shadows across the remnants of our solar system. The once vibrant planets and moons will become cold and lifeless, their surfaces scarred by the eons. Yet, even in this final act, there is a sense of cosmic poetry. The atoms that make up our solar system, forged in the heart of a dying star, will be recycled back into the interstellar medium, where they will eventually contribute to the formation of new stars and planets. The story of our solar system is a reminder of the vastness of time and the ever-changing nature of the cosmos. It is a story of both beauty and destruction, of creation and renewal. As we continue to explore the universe, we gain a deeper appreciation for the delicate balance of forces that shape the cosmos and the preciousness of the time we have on this planet. If you aren't too full of doom and gloom, please give the video a thumbs up and check out one of the 2 other videos currently showing on your screen. Thanks for watching and keep looking up.